Hi guys, in this video we're going to take a quick look at electrophiles and nucleophiles. Now, many organic reactions involve the reaction between a molecule rich in electrons, which we call nucleophiles, and molecules with electrophilic centres, which is a centre which is deficient in electrons, electrophiles. Now, nucleophiles are often defined as electron pair donors or lone pair donors, but it really should be electron pair donors. Examples of such species would include water, and you can see that water has got two lone pairs. So when this reacts as a nucleophile, it can use one of its lone pairs to attack an electron deficient centre. It's usually a case of the negative here attacks a positive. Other examples would include alcohol, which again is basically the same as water, but replace a hydrogen with an alkyl group, and again that has two lone pairs. Other species which could behave as nucleophiles, amines, which has got one lone pair on the nitrogen, and we could also have stuff like thiols as well, which is a sulfur nucleophile. But obviously these are all species with lone pairs, and species with a lone pair potentially behave as a nucleophile. But obviously we can get species like alkenes, things with multiple bonds like this. This could also here behave as an electron pair donor as well, coming from two electrons in the double bond. And these are usually all species, that have got a delta minus on them, more often than not. And this is kind of a region of electron density as well. And these regions of negativity will try and attack molecules which have got what we call an electrophilic centre, some region of the molecule which is deficient in electrons. And there are many examples of these, so let's have a look at electrophiles. And a common example would be a carbonyl carbon. And because you've got a polar bond here, where the oxygen is delta minus and the carbon is a delta plus. So obviously we've got what we call an electrophilic centre here, because this carbon is a delta positive because it's got a lower electronegativity than the oxygen, which will mean that these nucleophiles here with this delta positive, delta negative, will be attracted to this here. And what they usually do is they use these lone pairs, or this pair of electrons in a pi bond, to attack and form new bonds with that carbon. Now, these carbonyl carbons are usually susceptible to attack by nucleophiles, and depending on what is attached to this, what else is attached, so let's just say I've got an R group there, and let's call this Y, how reactive they are towards nucleophile will depend very much on what this Y group is. Other groups which can be attacked by nucleophiles would be stuff like alkyl halides. So again, this is a delta positive, this is delta minus. So if this X is a halogen, such as fluorine or chlorine, again, you'll have a delta positive carbon, and that can attract, potentially, these nucleophiles here. There are other species as well. I mean, let's have a look at one which doesn't contain a carbon, but you've got this species here, which we call a fluorophosphonate, and this is present in insecticides called organophosphates. And again, you've got a delta positive phosphorus there, which can be attacked by these nucleophiles. So what we get then in many organic reactions is a nucleophile, which can contain a lone pair on usually an electronegative atom, or for example a double bond, which is a region of high electron density. They can be attracted to electrophilic regions of a molecule, and that is ones that have got this delta plus. And again, these are all delta plus because of the polar bonds. These carbons and this phosphorus are all bonded to elements that are more electronegative. So remember, it's always the negative regions of a molecule. The nucleophiles will attack the electrophiles. Okay, and what we'll look at in a later video is specific examples of these nucleophiles and electrophiles in certain types of reaction.